general audience, I'm going to demonstrate the LAS X Navigator, which is here. Very useful tool. So the system has been initialized with including the stage initialization step. So if you remember, during startup it asks to initialize the stage or not, so you have to select yes in order to be able to use these stage experiments. So when you click the LAS Navigator, you're going to come to this interface, and it has two tabs. So this is the acquisition tab, and all of the menus that you are, let me close, that you're accustomed to see here, like acquisition mode, image parameters, illumination settings, all of them are available, but they are hidden to make a large window for the navigator. So I already tried to take an image here. So when you start, of course, this entire area is going to be clear like this. So let me remove that as well. So when you start the LAS Navigator, you're going to see something like this. As I said, this is the project menu where you have the files and images, beam path, acquisition properties, illumination, all of them are available. So, and down here you can see there is a spiral button, and that's a good thing to start with. When you click this, let me close this, it starts to spiraling around that position. As you can see, it gives you an overview of a large field of view. Here are a couple of spots that I imaged earlier, a little bit burnt or bleached. So once you create an overview like this, and then let me get a little bit more. I'm rolling the mouse wheel to zoom in and out. Also, I can move the image around by the left button of the mouse. So I'm going to stop here, and I'm going to take a tile image up here where the sample is not bleached, and taking the tile is very easy. So I grab this rectangle, and then I draw this. As you can see, it immediately calculates how many tiles it needs to cover that area, even if the parts that you didn't visualize with the spiral will be included. So now if I press this button, start here, it's going to acquire this tile. But before that, I want to show you a very useful feature. As you can imagine, sample may not be completely flat, and because of that, the certain parts may be in focus, like you see here, and certain parts are not in focus. So you can see these parts are not in focus. One way to overcome this is to take a Z-stack in addition to tiling, but that's going to be lots of acquisition, lots of frames taken. So there is this focus map that you can create. So with that you can define kind of different Z position for different parts of the tile that you're imaging, and it's going to acquire according to that focal map that you create. And in order to do that, you need to add several points to this. So I'm going to add one here, there. So you can add as many points as you like, but you can imagine it's if you're doing huge tile, then you have to go into each of them and set the Z position. After you're defined a few points, then you're gonna press this focus map. And you can visit each of them by just clicking. Once you go to that position, you adjust the Z. There we go. And once you achieve the clear focal plane, you do, let's see, set Z. Once you create, so once you press this set Z button, as you see, it recorded the Z position. And then you go to the next one. We're still live. I adjust the Z position, set Z. So this is what I was talking about. When you create too many focal points, then I mean, it takes time for you to visit all of them. But of course, more points you have, nicer or more focused image you're gonna get. So as you can see, there are some other options. Find the remaining by out of focus, which is possible, and let's try that. When you do that, it goes and takes a whole bunch of images and identifies the focus based on the contrast. So this would be kind of hands-off way to set these focus map points. But you need to be careful with that, because as you can see, it's taking a whole bunch of images. There is a potential for bleaching the sample when doing this. So as with most things in life, there is a trade-off between, you know, convenience and some other the benefits. But if the sample is, you know, mounted and you're using the excitation intensity which is not too high, then by all means you can do this. So there are a few more points to go. Oh, that was the last one. Okay. So now, as you can see, we created this focal map. Close it, and I'm just zoomed out a little bit, and I'm gonna, if I press this, I'm gonna get we're gonna create this the tile. But before that, if you double click at any point of this, oh, we're not live, sorry. Okay, when you go live, you can click, zoom in any point. So I'm trying to check. Did we bleach this so much? Interesting. I don't see see anything now. Okay, let's go check the beam path. Image, alright, 100, illumination, let's go up just a little bit. Oh, we're there, just maybe we glitched a little bit. So I just wanted to check the what exposure and excitation intensity I needed to use. So that looks good, and I want to check the DAPI as well. So I'm going to check to DAPI, switch to DAPI and take a look. Looks fine. So exposure I'm going to set 200 just to bump it up a little bit, and I will do the same thing for the red channel. So I went here and switched the cube, and then went back to image and assigning 200 millisecond exposure. So now everything is ready as I want it, and we're ready to talk. Oh, one other thing, you can merge the tiling right after the acquisition is over automatically, or you can do it afterwards manually yourself. So if we check this one on, then again there are some other options. You can keep the raw data on as well, in addition to creating the smooth tile. So I'm going to leave everything as default. So now I press, and zoom out, move around. So as you can see, it's going around and acquiring the tiles. So this is 7 by 8, 56 individual tiles. All will be merged as one large image. You can zoom in and check the individual tiles. Looks like we have a mega mitochondria here potentially. This is the auto scaling range for the image display, and you can hide the channels if you want. Also, you can change the display by adjusting the lookup tables manually like this. Click auto range, put it here. So you can change the gamma, but keep in mind that these are just for displaying the image, and it does not actually change the data. So our tiling is done, and if I go to projects, I can see this already merged and saved. It does not show the tiled image without these frames, so you can quickly close, exit out of the navigator, and here's the individual tiles. You can see all of the 56 frames of the raw images here. If you for some reason need to access or analyze those individual frames, and this is the tiled image. So out of change the lookup tables, this one as well, auto scale. So now, as you can see, we have this nice tile acquired automatically with very little manual labor. So I'm gonna show you one more thing with this. So if I go down on the scale range to display the image, it's not too bad, but you can see these are the regions, like the ends of individual frames. You can see they're a little bit dark, so you can flatten this out by using something that's called shading. So let me show you how to use that. So you can access it from here. So as you see right now, it says shading is not activated, or you can access it from the Navigator as well. So if I go back to Navigator, everything is there. And if I delete all of this, again, I'm going to start from scratch. So we are going to do, we're going to activate this linked shading. So click it and check, activate. So now, as you can see, this turned red. Red means it's activated, but there is no reference that exists for this objective. And you can create the reference by using the wizard. So just follow the instructions, and if you say, as you can see, it says press the button store XYZ positions, means that it's gonna keep where the position is right now, because in order to create this shading reference, we need to move the Z and potentially the sample as well. Well, I'm not gonna move the sample because I want to retake the same tile, but I'm gonna lower the objective to create this shading reference. So first thing, we store the XYZ position, and then go to the next tab. So it shows the objective that we're on right now, and what cube, what camera, everything. So if you press start, then it's going to take, or it will attempt to create reference for all of the objectives, but we're not going to do that right now. We will create the reference only for this selected objective that we're using, because I don't want to go through all of the objectives and create it for each objective. So if you remember, it said to go down, so I'm gonna go live here. Alright, I'm going to lower the objective way down so that I pretty much don't see anything. Then go to acquire single reference. So now this objective has this green button on it because we just created. And if for some reason you're not happy with it, or it doesn't work for your next sample, you can always delete and recreate. Now, without closing, I'm going to go to restore and press restore XYZ position. So it came back to where I was. So now this link shading activated, and it's shown in green. Also it says there is a reference available. That's why it's green. Now I'm just going to press and acquire the same tile with shading activated. Well, one thing I'm noticing is the Z position is a little bit off, and that's probably, I'm going to stop this. You know, there is some mechanical drift, so I'm going to go and quickly redefine the focus map. And I'm going to do it manually. I'm refocusing, as you can tell. Okay, set Z. Needs to update. Go to the next one. So, me lowering the objective, I mean, these are mechanical devices, I guess. They're not like super precise, and again, there is some, there may be some draft or temperature change, you know, subtle changes which changes the focus. So, create the shading reference, I guess, before you do this. So as you can see, manual defining focal map manually is could be a little bit faster than defined by autofocus, because we're not spending time to take a whole bunch of images. And as I mentioned earlier, it spares your sample, minimizes bleaching. And if at any point, if you want to add more points, you can do that. You grab this and then you click to position. Alright, so I'm going to go back to the focus map, and as you can see, this last point does not have the Z reference, and I'm going to set that. Alright, now we're ready to redo this tiling again. Yeah, now the images look much better, they're sharper. You can tell that by the previously acquired image and the new image that it's acquiring. This Mosaic merge tab over here is what you can use if you did not automatically merge them during acquisition. Also, to point out some other features, so it can record all of these previews if, you know, for some reason you want that large image saved, so you can save all of these. Now I'm going to go back, so Mosaic merge. It's merged right now, but if it was not merged, then I would choose this individual tiles, and this click the merge button here, then I would create the final merged image. So the difference here, so this is the tile scan. As you can see, it's a little bit different because here the images are just side by side with 10% overlap, but this one is after applying the smoothing algorithm. So it applies that algorithm to the edges, to the borders between tiles, and merges them by finding features, making the image look very smooth. So I'm going to close out of this, and I'm going to take a look, see if those the borders between frames are less visible or noticeable here. The one that we did earlier was this one. So look at this. You can see this little dark regions, this pattern, and those are the borders of individual tiles or frames. By applying the shading, we created much more smooth image. So, and that shading again is this function. We activate it and we created a reference just following this easy to use wizard. So that concludes the demonstration of LAS X Navigator. It is very useful and powerful tool to take this kind of large images. And I did not show you, but let me quickly show you. You can acquire multiple regions, and also they don't have to be square or rectangular shape. For example, if you're imaging a piece of tissue and you want to capture without some extra regions, then you can define shapes like this, which captures all the necessary tiles to create a large image of that entire tissue. So as you can see now, I defined 3 different regions, so you can acquire multiple tiles within the sample. And it also has this carrier function here. Here you can actually define if it's a slide, then it knows, but here you have to be careful. I would not actually recommend using this because we are using the universal insert. In order to use this feature, you have to use this exact holder that comes from Leica. Well, but if your experiment, really requires this type of automated imaging of the entire slide, then see me, we can place that holder and use this feature. But without this, I don't recommend using these pre-configured profiles with the adjustable universal holder, because you may run into the edges or bump the objective to the edges of the holder, so it is not recommended. So again, there are lots of options. As I said, very useful and powerful, but in order to use them, please consult with me first. Close out of this. I guess it stays selected or not. Okay, there we go. And I can just zoom in and go back to where I was. So yeah, that's the demonstration of this very powerful LAS X Navigator feature on the wide field. The same Navigator exists on the confocal as well.